Well, it's 10:15 on a Tuesday night, and I'm going to try to at least diagnose one more amp for the day. In general, I finish and do more amps than you see on the channel. I tend just to show either the most common things, like the Blues Junior bias stuff, or little tricks like the Silverface bias stuff, or intrinsically interesting amps. But, you know, if I get 4 Blues Juniors, only one makes the channel. I have 3 Hot Rod Deluxes and DeVilles and a Blues Deluxe here at the same time. Usually only one of those makes it. And anyway, this is a Fender. Can't tell if it's an 86 or a 76 twin. I think it's a 76 where the front panel was painted. I'll show that in a minute. The codes have a 6 here, so it's 76 or 86. I know it's not a 66. Let's see what's waiting for us under the doghouse cover. The owner says output tubes are red plating. It came in with only 2 6L6s in the amp, another pair of 6L6s seemingly brand new in boxes, and the twin only had 1 speaker installed. There's an impedance mismatch thing you can do with different loads and only 1 pair of speakers, 1 pair of tubes. I think it's someone was chasing lower output levels, though this amp does have a master volume. Anyway, let's look and see what's underneath the doghouse cover. All right, so the original filter caps that look okay. I'm just going to measure them for a dead short before I even worry about powering it on. Just because they look okay doesn't mean they're any damn good. But first of all, let me set it to DC, make sure there's not anything in here waiting to zap me. A little less than 1 volt waiting. Put it out of standby, and that 1 volt should go away. Yeah, there it goes. See, these 2 caps, the series filter caps, aren't affected by standby, and they've got these 220K voltage balance resistors, though you can't see them, they're hidden underneath. So when the amp's powered off, but the amp is in standby, these caps can't drain. But now that it's out of standby, these caps have drained as well through those voltage leak resistors. So now let me set it to ohms and check every filter cap for a dead short. 1.5 meg. Okay, see what I'm doing on the other side. 8 meg. That one's low. 1.5 meg. 1.4 meg. 1.3 meg. Those are all measuring lower than they should, but none of them are dead short. So let's flip the amp over and take a look inside. You get the front panel, you can see that blue stripe still there, and then the black paint. So I think someone just painted a 76. All right, starting down here at the business end of things. Tubes red plating. First thing I'm going to do is measure the screen grids and the grid stoppers on the output tubes. Even though only the outer sockets are being used at the moment. Let's see what this 470 ohm really measures. 520 something, so that's not bad. This one's not being used. .4 meg, so that screen grid resistor there has opened up. Maybe the owner wasn't pulling tubes for an output trick. Maybe this is the pair of tube sockets that was red plating. 510 ohms there. .478 ohms there. Let's check the grid stoppers. It's a little bit tricky to do with the camera here. It's supposed to be 1.5 Ks. Let's see what we actually have in here. If one of these grid stoppers has gone south, all bets are off. I'm getting I just tarnish on the solder. 1.7K. Both the solder and the leads of the resistor are tarnished, and it's hard to measure. I'm getting very high readings in the megs here on this one. So this usually doesn't take this long, but there's just so much tarnish. It's hard for the meter leads to do anything. Again, I can't get a measurement on that one. It may be open. And on this one, it's all over the place. So I don't trust any of those grid stoppers, and I don't trust one of the screen grids. The rest of the amp, stock Mallory bias caps, stock Mallory cathode bypass caps, all those things that normally need to be changed. It's got that 10 nanofarad I discussed in the other silver face video I talked about today. It's got the bias balance pot, which I showed how to fix without making sweeping changes in a different video on the silver face bias today. And it's got that later push-pull boost master volume I was talking shit about earlier. If we get this amp working, I'll be able to demonstrate why I think that. All right, what I'm going to do is make sure the amp is in standby, and I'm going to power it on with my light bulb limiter. Actually, I'm going to do one other thing first. It's got this add-on replacement power plug here. I'll make sure that that ground really is ground. Sometimes people don't wire them, and I would replace the power cable in an amp like this. I don't trust these old connectors, but first of all, make sure that ground is ground and that it was wired correctly. Before I apply any juice. All right, yeah, that's ground. All right, so we plug it into the light bulb limiter. So if there's a short condition, the bulb will glow rather than any fuses blow. And before I power it on, I'll make sure that the fuse installed is good and the correct value. Should be a 3 amp, I believe, or 4 amp, 3 amp according to the label. And it is a 3 amp. It is good. Sometimes with modern wall voltages on twins and such like this, you need to bump that 3 amp up to a 4 amp. And if you have a twin that blows 3 amps and seems otherwise healthy, you can go up to a 4 amp. If it blows that, you got a problem. But typically, a 4 amp is the more modern choice given current wall voltages. No pun intended there. Let's power it on. In standby, very much in standby. I'm watching the meter for any glow. All right, the jewel is a little bit loose, the bulb, but the light is on. And the first thing I want to do is check the voltages at pin 5 of each output tube to make sure that there's bias being sent to each tube. If that goes away, you have red plating and worse. Negative 37.9, negative 38, negative 38, negative 38, but it fluctuated negative 16 for a moment. Huh. All right, now I'm going to, these tubes, all right, I see the heater glow on them, but I'm gonna power the amp off and pull these two output tubes. That's broken off in the socket. Seems to have been aligned correctly though. These tube sockets are loose as can be. I push the keyway out of that hole if it's there. Now that keyway is long gone. If the tube's still good, I can glue on a new keyway, center hole. All right, power the amp on, take it out of standby. Still no glow showing too much current. I want to check the voltages at the screens and at the plates. This will be high with no tubes in place, but 452, 449, very consistent. So all the voltages are in the correct range. Does not mean that the resistors are any good. It just means that with no current through them, they're not acting up. Let's put these tubes in. Worry about the tension on the sockets later. This is one with the broken keyway, but here's the pin 8. So, all right. And I'm gonna move the camera so we can see those tubes. All right, I've got the bench light off and it's dark outside. So as I take these out of standby, you'll get a good view if there's any light show. Here's one tube. Well, you can't see where I'm pointing, but you see those two glows, left and right. Those are the heaters of the 6L6s. A flash of blue meant the current was going through, and the light bulb limiter has a steady orange glow, but it's not bright. I've got the master off, the reverb all the way at 0, and the channel volume's at 0. Let's bring the master up. That'd probably be good if I plugged in a speaker. Sorry. Having a wonderful time, but I'd rather be whistling in the dark. Let's see. Speaker, speaker, speaker. Here we go. Don't worry, I didn't hurt anything. I had the master all the way off, and the speaker jacks on these fenders ground out when no signal is applied, so there was a load. I got the normal amount of hiss I would expect in the background. Right, this tube here is microphonic no, it's not a microphonic, just a loose, dirty socket. The one on the right's got a bit of a blue glow, but it's faint. This is the reverb channel. It's got a pretty good hum. And it's dirty pots. Normal channel. All right, this era, I don't think we're going to have any dramatic light show from the tubes. This one's got a little bit of a blue to it. We turn the light on. And show you what I want to show you. This era of Fender has got a hum balance pot here, which is pretty much a terrible implementation in that It is rarely fully tight to the chassis, which is how it makes ground. So let's make sure it's tight before we do anything else. Yeah, it's spinning. Let me power it off so I can tighten it up without zapping myself or breaking a wire. Yeah, so I did not have a good chassis connection. Now it has a much better one. And there's just an awful lot of current through a 1/2 watt pot. I, in general, disconnect these and just put in a pair of 100 ohm resistors, which is a better way to get a hum balance. But for right now, we're just going to make sure that this doesn't need to be adjusted. Though I suspect that the filter caps are problematic. Let's see. Made it worse. The screwdriver doesn't want to grab. Let me go to the next size. Can't. It's like it's frozen up. Get a look at it. That's much better, don't you think? All right, that dirty dirt volume pot is going to drive me nuts. Let's take a look at it real quick. Just going to give it some deoxit. See if that makes that noise go away. Much better. All right, there's a bit of hum I don't like. Let's see if it's just the jack's not shunting. Yeah, it's not shunting. Let's see if cleaning the jack makes that go away. So I'm going to turn the master all the way down. Plug a guitar in. And see if there's just some corrosion here or if it needs new jacks. So just cleaning the contact between those two pieces of metal, though I don't think that they're making good mechanical connections. Let's see if that did the trick. I suspect this amp needs all new electrolytic capacitors and new input jacks. Yeah, metal is just fatigued. I've not been able to rebend them once I get to this point. I've been able to fix it for maybe 30 minutes, but later it quickly moves back to where it wants to be. So that's the hum we should have. That's the hum we have. Let's see if the same thing's happening on the normal channel. Yep. Just good old-fashioned metal fatigue. Not as bad. That one may clean up, though it'd probably be better just to give it new jacks, because if it's on the way to full metal fatigue, it's just delaying the inevitable. Any electromechanical connection, a pot, a jack, a switch, is rated for X number of mechanical actions, whether that's a rotation or a click or a switching. And you get so many, and then it wears out. Just the nature of the world. And a Switchcraft jack is about $5 if you pay full retail. My price on them is quite a bit lower. Yeah, that one cleaned up, but I would rather change it out. It's got some tarnish on it. This one over here, though, just needs to be replaced. So we're looking at 4 input jacks. putting in a better hum balance circuit than this old pot because it's a bad idea. Replacing every electrolytic in the amp, just like you saw on that 73 Vibrosonic, and changing this 10 nanofarad to 3.3, putting in a bias level adjustment, not just to augment the bias balance, and probably leave the boost circuit in. Just tell the owner don't use it, it sucks, but remove, you can't see what I'm pointing at, remove the damn bright cap from the master volume, because that's what makes it suck, that bright switch. If the bright cap, if the switch itself is defective, then I'll replace this pot with just a simple 1 meg audio and leave the boost stuff disconnected. There's no inherent reason for these amps to sound bad, other than old electrolytics, a couple of the CBS era design flaws, like here, just like that 73 today. It's got an unbypassed 470 ohm resistor, maybe one of the larger ones. Sometimes in the later ones they went to like 680. Let's see what this is for the 12AT7 cathode, which inevitably either burns the resistor or burns the cathode or burns the AT7. It's a 542 ohms, so it's a 470 that's drifted just slightly or wasn't really in spec. And the fix for that is to put a 2.2K in bypassed with a 22 microfarad cap, just like the AB763. Let's check one other thing before we stop for the night, and that is checking for DC leakage on this waxed board, just to know what I'm up against once the recap and power cable and other mentioned tweaks are done. Let's see what we have in terms of DC present on tone stack stuff. 0 volts, that's good. That's good. Good. Let's check here at this coupling cap. If I can see it. 60 millivolts, that's really good. 0, 0, 0, that's all excellent. Here, where there's almost always some leakage, only 20 millivolts. This amp is beating the Silverface odds. So that's really good to measure. Let's see what I'm getting on the wax itself. 80 millivolts, 60, 30, 30, 7. And here at the mix resistors, 62, which is coming from that coupling cap there, and none coming from that coupling cap. So the only place we've got any significant DC leakage in the wax is right here on this 47 nanofarad coming off the normal channel. That's stellar. So let's move the pots around. A little bit of yuck in the mid spot here. Oh, that's good on the reverb channel. A little bit of yuck in its mid spot. Bass is good. Reverb pot sounds fine, and it's noise just because there's no tank connected. Intensity and speed we'll check later. Master volume pot's a little bit of static. Let me clean that real quick. All right, so I need to talk to the owner tomorrow and see if these tubes were red plating or if he had tubes in here that were red plating. There are 2 brand new giant JJ6L6s that came in 2 boxes. And I don't know whether they were in the amp and they were red plating or whether his tubes were red plating. He sent the amp in for me to check it all out. And those were some spares he had. I will find out more and add that to the next video on this amp. But, you know, this is how I evaluate these things. At least the most common things to check for. And once I know that all the electrolytics have been changed out and they're good and there are no gotchas, and I'm going to have to change the screen grids and grid stoppers on these output tubes. Even though they measured okay with no current, I was getting crazy values or lack of values when measuring the resistors themselves. I just don't trust that. There's no reason this amp cannot sound every bit as good as that 73 earlier that you heard earlier today, or I guess it'll be yesterday by the time I post this. Other things I always do is make sure that all the jacks are tight. Sorry, I got tangled up. Need to go in here and clean off these RCA connections. That makes a huge difference for the reverb connections especially, and gets rid of mystery noises when using a pedal to switch things. So overall, this amp's in great shape, and I look forward to hearing it in all its finery. And there's my trash can. What a great shot that is. So, Fender Musical Instruments, Fullerton, California.